Lesson 1.7 is titled Vertical Angles Theorem. As you watch this video lesson, please take the time to write everything that I write onto your note packet. Let's start with vertical angles theorem. It says angles formed by intersecting lines. Vertical angles are congruent, so please add that word to your note packet. Taking a look at the diagram, what makes vertical angles unique is that they're directly across from each other. So like angle 1 on that left-hand side and angle 2 on the right-hand side are vertical angles. So we can write angle 1 and angle 2 are vertical angles. It's also true for angles 3 and 4, but they're not necessarily the same measure. That means we would do a double arc for each of those. Angles 3 and 4 would be vertical angles as well. So for notation, because we're working with vertical angles, we would state angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4. And there's your notation. Now, kind of formed in this same diagram is our next definition, a linear pair. A linear pair are two adjacent angles that form a straight line. They have to share the same vertex, and adjacent means they're right next to each other. So a picture that would represent this would really be just kind of half of the picture up above. If we draw a straight line, we'll just go straight across like so. I'm going to pick a point anywhere on that line, and then I'm going to draw my ray anywhere above that line, like so. And this time I'm going to label my angles A and B. Now, if it's a linear pair, that means it has a specific rule. It's going to add up to a number, and we actually talked about this last week on one of our activities. The measure of angle A plus the measure of angle B is equal to 180 degrees. That's the definition for a linear pair. Linear pairs are known to be supplementary angles. It says when the sum of the measure of two angles is 180 degrees. We're going to have two sketches, one that's going to really look like linear pair up above, but then another example that doesn't. So if they're adjacent angles, it's really just the exact same picture. So I'm just going to repeat my picture up above. And I'll say maybe this first angle on the left is 130 degrees. Then the angle on the right would have to be 50 degrees. So this is just an example. Together they add up to 180. But then look at to the right. It says non-adjacent. That means they don't share the same vertex. This picture is a little trickier. I'm going to pick a point and draw my ray to the left like it's the bottom part of the angle, and then extend it up to the right and give that a measure. Let's say this one is 120 degrees this time. So then I'm going to slide over to the right a little bit and draw that right-hand side of my angle, put a point so that it's a different vertex, and then run it up in the same direction. Now that smaller angle on the right would be 60 degrees, making their total 180, and that makes them supplementary. Another way to compare the sum of two angles is by using the term complementary. If two angles are complementary, that means their sum is 90 degrees. So if we look again at the words adjacent versus non-adjacent, for an adjacent pair, I'm actually going to draw what looks like the letter L with arrows at the top and the side. So we're still creating an angle. And then to verify that it's 90 degrees, we're going to put that little box in the corner like so. And then my vertex is down here. Now we can divide it up any way we want. I'm just going to draw kind of a ray through the middle over here. And let's say that this angle at the top is 70. And then that little angle on the bottom would be 20. So they add up to 90 degrees and they're connected. Versus non-adjacent to the right, start off the same way. I'm going to draw that top ray up above. And then I'm going to put my point, oops, maybe right there. And I'll extend that out like so. So maybe that's 30 degrees. Over to the right, I'm going to change my vertex. So I'm just going to draw my arrow to the right and then run my other ray up so that kind of the same direction. And this angle then would be 60 degrees. And that way, when you add the two together, it would equal 90. So sometimes you'll have just one number and you have to calculate the other number. Pretty easy. But then sometimes we're going to have variables and use a little bit more algebra to solve. And that's it for our terminology. Go ahead and flip your note packet over to the next page and we'll work through some practice problems. All right, let's take a look at example 1. Using the diagram, identify a pair of vertical angles. Well, if we take a look at our picture, I see more than 2 intersecting lines. There are actually 3 intersecting lines. But remember, the definition of vertical angle are angles formed by 2 intersecting lines. Let's zoom in and take a look in more detail. There we go. If I wanted to take a look at just 2 of the lines, I'm going to draw over this line right here with my arrows. And then I'm going to go just below that angle 1 and do the same thing. So there's a pair of intersecting lines. Notice on the left-hand side, angle 1 is directly across angle 3 on the right-hand side. So angles 1 and 3 are a pair of vertical angles. Let's write R vertical. Can you see another pair that wouldn't be related to 1 and 3 at all? If I take a look at the other line that was drawn in, or that's on the picture, we'll draw that in orange right here. I see that that connects to angle 2, and the other line that's used to make angle 2 kind of goes back through here. I can see on the picture that angle 2 is vertical with 30. So we could also say that angle 2 and 30 degrees are also vertical. I know it said we only had to name one pair, but I just wanted to let you know that there were 2 choices, and both answers are correct. In our next example, we're going to have some fun with algebra. It says find the value of x and the measure of each labeled angle. Taking a look at the picture, I noticed that we have angles formed by intersecting lines. The angle on the left and the angle on the right are vertical angles. So let's write that word vertical at the bottom. And because vertical angles are congruent to each other, to solve for x, the first thing we're going to do is set the values equal to each other. So to get x by itself, we're going to set 6x minus 45 equal to 4x plus 5. And this is just algebra now. We have x's on the left side and right side. To get them on the same side, I'm going to take the smaller value for the number and move it over to the bigger one, like so. 6x take away 4x, we have 2x left over. Minus that 45, we haven't moved that yet. On the right-hand side, the 4x's cancel, and we're left with positive 5. So we have to move that negative to the right, meaning we're going to add it, as the opposite sign is what makes it go to the other side. We still have 2x, cross off the 45s. On the right, 5 plus 45 is 50. Our final step to get x by itself, divide both sides by 2. That cancels out. On the right, 50 divided by 2 is 25. So that's one of our 3 answers. Once you know the value of your variable, let's go ahead and go back to the picture. I'm just going to slide this over here like so, and determine what each measure will be. If we know that x is 25, over here on that left-hand side, I'm going to take 6 times 25 minus 45. 6 times 25 is 150. And if we subtract 45 from that, we have 105 left over. So let's go ahead and underline that. Over on the right-hand side, let's verify that x is correct, and hopefully we get the same number. If we plug 25 in for x on the right, we get 4 times 25 plus 5. 4 times 25 is 100. and plus 5, oh, get this. Look at that. We got the same answer. Again, double checking that by plugging it back in verifies that your x value absolutely is correct. So I'm going to have you try the next one on your own. Let's take a look. Really, it's the same set of directions. Find the value of x and the measure of each labeled angle. So go ahead and pause the video. You don't have to write the word pause, but pause the video and see if you can set up an equation to solve for x. Once you solve for x, find the measure of each labeled angle. After you've done those three things, press play and we'll see how it went. All right, let's see how you did. Recognizing that we have a pair of vertical angles once again, we know vertical angles are congruent. I set the two values or the two parts equal to each other, and I got x equaled 19. When I plug x back in, I got the angle on the left to be 132 degrees, and the angle on the right was the same value. Again, that helps verify that our answer for x is correct. We're going to end the video lesson with the application problem at the bottom. The diagram shows how glass lenses change the direction of light rays passing through a telescope. What is the value of x, the angle formed by the crossed outermost light rays through the focal point? So that's a lot of information, and as you look at that picture, we can kind of visualize the telescope. But then down below, it gives us an even easier picture to kind of focus on. So if I zoom down to that picture below, we want to try to figure out the connection with x on the right-hand side and those values on the left. Well, I see x is formed by the black line and the orange line. Those are the intersecting lines. So if I kind of just draw through those, I notice that x would be a vertical angle with the two angles on that left-hand side. So even though this is an application question, all we have to do is literally add the 11s. How great is that? The value for x that makes this a true statement is 22 degrees, because x is a vertical angle with the values on the left. And that's where we're going to end the lesson for today. We'll finish the rest of the notes in class.